Yeah, good afternoon, everyone. I, Dr. Sharat Chandra Pathi, welcome you all in this today's lecture. VIT Bhopal University is celebrating National Science Week during 22nd to 28th of February to commemorate the discovery of Raman effect by the great Indian physicist Sir C.V. Raman. In this lecture series, today's distinguished speaker, Dr. Carlos Gabriel, has joined us. Dr. Carlos Gabriel is the chair of COSPAR Panel for Capacity Building Committee on Space Research. He is joining from Germany. So Dr. Carlos Gabriel was born in 1956. He grew up in Argentina. He completed his PhD physics studies in Heidelberg University in 1985, and he received his doctorate degree later in the field of particle physics. So after several years as scientist at Max Planck Institute for Nuclear Physics and the Max Planck Institute for Astronomy in Heidelberg, he began in 1993 a career as scientific of staff in European Space Agency, ended with his retirement in 2019. In these 26 years, he has mainly contributed to the scientific operations of two major science space missions, the Infrared Space Observatory and the X-ray Multi-Mirror Observatory, in the fields of scientific data analysis, software development, and instrument calibration. From 2009 to 2016, Carlos Gabriel was the chairman of the program organizing committee of the Astronomical Data Analysis Software and System Organization. He has participated since 2001 as lecturer in many COSPAR capacity building workshops. In 2010, he became responsible for the fellowship area of the panel for capacity building and later for the astronomy and planetary session area, planetary science area. Since 2018, he has been leading a PCB as chairman. So we are quite fortunate to have with us our today's distinguished speaker, Dr. Carlos Gabriel. On behalf of VIT Bhopal University, I welcome you, Dr. Gabriel, to this session. It's over to you, sir. Please.
Okay, thank you very much for the introduction. I'm going to share now my screen so that I can present you the COSPAR Capacity Building Initiative. And I call it the COSPAR Capacity Building Initiative, and it's New Horizons, because I'm going to talk also about the future of the project. And I'm doing this on behalf of the whole panel on capacity building. You see the names here. We have different people responsible for the different areas, which we are covered in all space science disciplines, or in many space science disciplines. We have also a sub panel, the Capacity Building Fellowship Program and Alumni, which was created just 2 years ago. Okay, but let me first tell you what COSPAR is. COSPAR stands for Committee on Space Research. The committee was established in 1958, and it was born just after the launch of Sputnik 1. The assemblies organized by COSPAR, the scientific assemblies, became soon the cradle from which the space research community developed, and they gave rise to many international projects from which we continue to benefit today. Its main aim is the promotion of scientific research in space on international level, and with a very strong emphasis on international cooperation. This was especially very much needed in 1958, because these were times of Cold War confrontation, and COSPAR represented a bridge between East and West for scientists to be able to talk to and collaborate with each other. Okay, you see here the statement of principles of COSPAR, the promotion of scientific research in space at international level. There is always an emphasis on the exchange of results, on information, and even trying to impede geopolitical tensions or differences. And there are words about highest ethical standards and the zero toleration of any form of discrimination or harassment. And so it was the spirit of the time of part of humankind who was trying to reduce the levels of confrontation which were at that time in the world, making it very unsure. Okay, in summary, COSPAR is mainly a forum open to all scientists in the world for handling all aspects of space research. Its members are national scientific institutions where the institution is representing a country, plus international scientific unions. Indian representative within COSPAR is the Indian National Science Academy. So you see here a world map with all the COSPAR member countries. There are 46 at the moment, which together with the 13 international scientific unions compose the 59 COSPAR members. But let me now come to another map. This, what you see here is a representation of the level of scientific research in the world through the number of researchers per country normalized with their population. As it cannot be expected differently, the map shows profound inequalities related directly to the level of development of each country. We know that there is a strong correlation between scientific productivity and present and future economic development of a country. There are even indicators favoring the basic sciences, stating that countries focusing activities in applied sectors grow actually slower than those doing it in basic areas. So we are putting a strong accent on basic sciences. And it is common sense that applied sciences research needs a basic sciences substrate. I would like also to stress that there should be a fundamental right that scientific knowledge is shared by the whole humankind. It is also important to underline that our domain, the space sciences, are especially important due to their wide acceptance because of the large public interest and the motivation they generate. It is not just by chance that the largest ideological confrontation of the second half of last century was crystallized in the space race. But space sciences are in principle expensive, and that's the reason why they were for a long time almost forbidden territory for developing countries. However, participation on different scales is always possible, as we will see. One of the big changes in the last decade of the 20th century in the scientific world was the increasing dissemination of scientific data, made possible by the upcoming of the internet era, but also by an open-minded scientific attitude. This dissemination took the form of more and more advanced archives. Here an example close to my heart by giving, this is the X-ray, the XMM Newton Science Archive. By giving a source name or a position, it's not only possible to download the corresponding data in the field, from this field, from the XMM Newton catalog, but it's also offering calibrated data, a glimpse of the data quality, all the images related and measurements with the different instruments, even all the sources detected in the field are coming together with the spectra and the light curves of every single source detected. This is also similar in other fields like solar physics or exploration, as in these examples with other ESA archives. The question here is that, oh, sorry, I wanted to show. So the summaries, there are vast amounts of data processed at different levels with a lot of ancillary data helping the understanding. offered publicly and easy to be gathered. But it doesn't end here. Also, analysis tools are offered by many projects. Again, something even more close to my heart, the software I have been responsible for almost 20 years. The scientific analysis software of the XMM Newton project. These free distributed analysis tools can be used to produce all the wonderful data you see here. And they get supported and maintained for years and years, because it is in the interest of the projects that their data are analyzed in the best possible manner. All these elements make actually possible that first-class professional research with just a laptop and a broadband connection is possible. These tools are mainly used, and they were in the beginning of the 21st century exclusively used in the developed world for making science. The two most important causes are the lack of knowledge, or the lack of knowledge about the existence of publicly accessible resources like this in developing countries, and a clear deficit in those developing regions in space sciences, since the related disciplines do not belong to the traditional local research areas. These were science for rich countries, actually. A clear impulse for profiting scientifically in developing countries from those resources could be given, therefore, through an educational program trying to revert this situation. And so the capacity building program was born, sustained by COSPAR, with the main aim of encouraging scientists from developing regions to make use of scientific space data and tools. This should extend the research horizons in those countries and make sure that local scientists are aware of the opportunities brought by those data and tools publicly available, instructing practically the students in the usage of archives and associated software, and also promoting professional bonds between the capacity building workshop participants and those experienced scientists who are acting as teachers and supervisors, reducing the isolation, the inherent isolation suffered by scientists in developing countries. A typical COSPAR capacity building workshop is highly practical, with 2 weeks of duration and with approximately 30 to 35 students and 10 to 15 full-time lecturers who act also as supervisors for the hands-on data analysis. These take some 2/3 of the time devoted to the workshop. Based mainly on data analysis with data from archives, small scientific projects are carried out individually or in groups, and end with a presentation by each student on analysis and results, in which the comprehension of the methodology and the ability to work with data and specific area tools have to be demonstrated. The learning needs go from the type of science, which normally are not well known, and the characteristics of the used instruments and data, to the usage of archives and analysis techniques proper of the scientific area. The students get to know the specific analysis software packages from installation to their use. And while the full workshop program includes lectures on science, software, missions, and instruments, the central part of it is the project, the practical work they're going to do for at least half of the time of the workshop. The typical duration is a compromise between needs and financial affordability, since all the costs of lodging are covered by the organization, and even the travel costs of all the students are highly subsidized. Here you see the program of the capacity building workshop we held in Alexandria, Egypt in 2008. This was on space astrophysics, gamma and X-ray astronomy in that case. You see that we go over the missions, the science, statistical and data analysis techniques in lectures, but also in the practical work performed during the project. Here, a typical timetable. This one is corresponding to a workshop on X-ray astrophysics, which we held in China, close to Nanjing. This was in an old observatory in the mountains, which was renovated for the occasion. So you see here the times devoted to science lectures, analysis programs and techniques, as well as to the project. And you see that the project takes almost 60% of the time. This is, by the way, the nominal time. Because in most cases, while the workshop progresses and the end of it, and with it, the own presentation of the students comes closer, the students tend to work also in the late evenings, even increasing a lot this 60% of the time. A fundamental point are the common meals and sharing the accommodation for the 2 weeks by students and lecturers. This proves to be the best recipe for strengthening the bonds between lecturers and students. Diverse social aspects are very important and covered. In the mid-weekend, normally we perform an excursion of students and lecturers together, and this is also fortifying those relations and adding up to the 2 weeks of working together. Some of our workshops have taken place in remote places. In other places, the isolation was generated by inherent difficulties to the place, to leave the hotel or the workshop venue because we were in some strange areas and so. So that we had to find out creative cultural activities like theater reading, music playing, karaoke, dancing, etc. By the way, if you look carefully into the pictures, you will see that I'm myself a famous piano player inside the world of COSPAR capacity building, by the way. The level of cultural exchange between the students from different countries and different cultures is very often fantastic. It's one of the pluses of these workshops. Okay, after the first 2 workshops in X-ray astronomy, it was at that time one of the most advanced space science disciplines in terms of data dissemination and offer tools. There was, after these first 2 workshops, there was a large broadening of the program to all space science disciplines. You see here represented magnetospheric physics, ionospheric studies, planetary sciences, solar terrestrial interactions, planetary surface sciences, Earth observations related to different things like water cycle, atmospheric aerosols, land surface characterization, all types of astronomy, oceanography, remote sensing for climate change studies, space weather, you name them, up to a very new discipline like crystallography for space sciences. I didn't know that something like that existed before. Today, most of the space science disciplines are covered by the program. In the last 20 years, we have performed 38 workshops in 21 developing countries with more than 1,100 students from more than 70 countries. You see the locations on the map shown previously, and of course you see also the correlation between the places where we are holding our capacity building workshops and the levels of scientific activity in those countries. In 2010, actually it says 29 here, but 2009 we have decided it. In 2010 it was implemented. We complemented the program with an associated fellowship. Fellowships are open to young scientists who have been participated at one of the COSPAR capacity building workshops. The objective is to enable participants to build on skills gained during the workshops. Fellowships consist of visits of 2 to 6 weeks to an institute for the purpose of carrying out joint research in those laboratories which are collaborating with COSPAR in organizing this fellowship program. Very often the hosting scientist has been a lecturer in the workshop the fellow has participated. The short research project has to be presented together by the candidate and the receiving scientist for approval of the fellowship. So far, 69 internships of this type have taken place. Now, how should our workshops help the scientific development in those countries of origin of our students? Because we are helping individuals here. Here is a scheme of how the typical career of a workshop participant looks like. Usually, the knowledge gained in a workshop represents either a new scientific area or a significant extension of the prior knowledge of the participant. Sometimes this is not going to cause by our students a fundamentals. By some of our students, it's not going to cause a fundamental change in their careers. We have had even some students who have participated in a second workshop on a different topic, of course, somewhat related, but in a different topic. For instance, infrared astronomy after X-ray astronomy. This means different tools, different techniques, etc. The analysis tools to work with are very often new, since they belong to a suite related to space sciences, poorly known in those developing countries. So it can be that the students stay in this new area or using a lot this new acquired knowledge. So if this means the change to a new area or the continuation of this student in this new area can be boosted through this associated fellowship. And very often the choice between staying in the country or going abroad for a while for specializations comes very soon after the participation in the workshop or in the fellowship, given the age and the characteristics of our participants, typically PhD students. If they stay in the country, then that's perfect. If they go away for a specialization in a developed country, they will have to decide after a while, after their specialization, if they go back to the country of origin or not. If they don't, then they can stay probably, they stay in doing scientific work in this new field in the foreign country, because this is what they have specialized in between. And they have the possibility to cooperate with the local science also. If they do, it's also perfect. If they go back to the country of origin, it's also perfect. What you see here is that there are several ways for our participants who have been trained individually to collaborate to the science work in the new field, in the original country. And this is the main aim of our workshops. Some important related points, which I like to stress: the workshops are held in developing countries having a strong regional character, This reduces the travel costs, increases the chances of regional collaborations. Data and software should be free available also after the event. As far as possible, open source software is to be used. We try to get our lecturers to stay for the whole duration of the workshop. Given the high level of many of our lecturers, this is not always possible. Sorry. Sometimes they are very busy people who are running laboratories, for instance. And it should be clarified that there are no honoraries whatsoever paid to the lecturers. Only the travel costs and full lodging during the workshop are covered in the same manner we do with the participants. But even so, we get these international well-known scientists to participate, many of them. And coming again to the next event, I always say that there is a special flair in our workshops, which are bringing those people to work for nothing and collaborating. Of course, a strong interest in the scientific area should be given locally, because what we are interested in is that there are chances for the participants to use locally what they learn. So in the developing country, and so helping this country. And this has to be expressed in a local financial participation of the order 25 to 50%, because this is showing that there is really a real local interest. So let me present you the list of workshops and fellowships in the last 20 years. You see the space science discipline of each workshop, the country where it took place, the missions related to, and as well as the number of fellows from them. These are the first 14-year, 22 events. In the next 7 years, half of the time, another 22. So you see that it's increasing with time. Of course, you see also here that there are many many workshops which we have planned for last year, for 2020, which have had to be postponed. They are still postponed. We're trying to get them done in 2021, but we have to see if this is possible due to the pandemics. So an important point is that our program acts on individuals, as I said, who in the normal case would contribute substantially to the science in the developing country, our main aim. However, those contributions are not under our control, and we have just some indicators about the effectiveness of our capacity building program, and have put in place some measures trying to get some quantitative answers. Because so far we have only qualitative answers to the efficiency question. So, for instance, the establishment of X-ray astronomy in the Latin American region after workshops held in Brazil and Argentina, where it was insignificant before, this was a good indicator. The boosting of this discipline in India and China, for instance, after the workshops we have held there, they could be inferred from the increased use of archives, but also by the number of proposals in the missions coming from those countries. However, it is difficult to measure quantitatively in these ways the effectiveness of our program. So we have some measures here. After each workshop, the COSPAR officer responsible for it has to write a report, including the results of a questionnaire filled in by the participant, or each participant. And we make it clear to the students that this is a very important point, and that they should be as critical as possible, because we improve the workshops through their feedbacks. The questionnaires touch all the different aspects of a student's participation, from the application to the actual participation, including the travel, the funding, etc. Special points are the judging of the quality of lectures and practical work, including the level, the pace, how approachable the lectures were even. And we do not forget the practical aspects, like the quality of the venue, the accommodation, or the food. Each questionnaire is tailored to the specific workshop, but in general, they are very similar so that they can be compared from workshop to workshop. They represent a kind of image at the end of a workshop for us to judge how it went. And the most important question is probably the one related to the future, to see if the student thinks that the workshop participation could have a strong influence in his or her further career. Of course, this image is not necessarily a good representation of the efficiency of the program, but just a time-frozen impression. We don't have the means to follow the individual careers of our workshop participants through this. We see just their status at the end of the workshop, and what we are interested in is what is happening in the future with them. As an attempt to judge better the efficiency of the program, we have created years ago a Facebook group. I was in a COSPAR capacity building workshop for exchanging information, requesting the members of this group to report on their situation, changes, etc., through files which are included in the page. As a vehicle for information exchange, the page works pretty good, and more than 25% of all former participants of a COSPAR capacity building workshop are members. Actually, these numbers goes up to over 80% of all the workshops if we take into account that people only, those workshops which took place after the creation of the Facebook group, which is collecting most of the members of the group. However, the necessary quantitative feedback for efficiency judging can't also be established either this way. And due to this, we have created just 2 years ago, we have started to create an alumni organization, which should help us in career tracing, as well as to help in maintaining actively the contact among the participants of a workshop. It's based on self-organization of the participants of each workshop, who nominate 2 representatives at the end of it, who are going to maintain the contact, be this through WhatsApp group, email lists, or whatever they want. This is a constantly changing world of social networks, so we leave it to the students to organize themselves. Our expectation is to have actually 1 virtual event yearly pro workshop, in which each participant should tell the others about the level of his or her research activities, relating these to the workshop participation, etc. The first one of this virtual event took place in December 2020, just a couple of months ago. And it was actually very encouraging, showing the large influence their participation in the workshop had for the further career development of the students. At this event, we had only 12 participants, around a third of all participants of the workshop. Several could not participate due to date and time of the meeting, but we have received some presentations from others. Each of the students gave a presentation of 7 minutes, with not more than 3 slides is what we allowed, and had some 3 minutes for question and answers. The main questions each presentation had to answer were: what are you doing scientifically at this moment? Has it any relation to your participation in the COSPAR workshop? To which extent do you think the workshop has an influence in your career? And any other consequences from your participation in the workshop. All the 12 participating in the alumni event are today actively working, every single one, in research, and most of them relate directly their activities today to the workshop they have participated. Even publications, at least partly, they were assigned to their participation in our workshop. Okay, needless to say, all 12 are working in a specific area of the workshop. This was also X-ray astrophysics. For some of them, this area was even new or partly new when they came to our event. They were astrophysicists, but they had not worked in this area. By the way, I'm talking a lot about the one specific area, the X-ray workshops, because I have participated mainly in those. Of course, if some of my colleagues in the panel would give this talk, he or she would refer more to his or her area. It's clear that's my experience. But on the other side, the X-ray astrophysics workshop are one of the main areas we are covering in our whole project until now. They are very productive and so. Okay. Anyway, the contacts. Sorry, I think this was already presented. Yes. Oops. Okay. Anyway, what I wanted to say, the final word on this, the contacts among the participants have been renewed through that Zoom meeting, and a lot of info exchange. New collaborations were born out of this meeting, and the proposal to organize another Zoom meeting with people from former workshops was done there, and we are going to do. Okay. Now, nothing is better to characterize our program than a good example, especially if I choose it and I take the best one. Let me call this just an anecdote, a discovery in a workshop. 7.5 years ago, we had an X-ray astrophysics workshop, another one in Xuyi in China. I have presented already something corresponding to it, the program. I'm seeing all the time hands which are raised. I don't know if you expect me to stop and give answers in between.
No, Carlos, we'll be taking the questions after your session, so you can complete with your presentation.
Okay, because I see hands raising. Okay, this was this workshop in Xuyi in China, on the mountain in this old observatory, which was renovated for that occasion. By the way, our regional students were mainly coming from India and China, half and half. They were representing some 45% of the participants from each country, and then the 10% were from other countries. One of the students, Pinso, clearly a Chinese, came to the workshop with an own project, which was based on the study of the supernova remnant case 79, which you see here in the image. She had selected 2 observations performed with XMM Newton for this project, But in one of these observations, she noticed a bright source in the south, if you look, in the second observation, a bright source which was not present in the former observation. These observations were some 1.5 years apart. Actually, it was a source detected by the XMM Newton pipeline, the pipeline processing we do with the mission. Thus, I'm retired now from that mission. This source was detected by the pipeline, which is running after the by the processing, by the normal processing, and as such, it had this telephone number you see here. But it had escaped the detection of what we call very interesting variable sources. This is something the pipeline does at its ends. Okay, if you want to know the reason, you can ask the proper question in the question and answer session later. She looked, Ping looked for possible technical explanations like failing detectors, some failures and so, but there were none. And so it was clear after several checks that this was a real source, meaning she had found a transient source, a source which is sometimes there, sometimes not. Okay, spectral analysis were performed during the workshop, not these ones which you are seeing here, because these belong already to the final publication of the results. But during the workshop, she did first spectral analysis, including the use of theoretical models for understanding the data, and even confirmed her assumptions about the nature of the object. The most important analysis, however, was a timing analysis, since this was the clue. She had discovered a transient source which showed an oscillating behavior in flux, as you see on the right side of this panel. And the power spectrum analysis gave a fixed period of 12 seconds and a very small decay of the period also, if at all. But with a large change in flux between the second observation and a later one of the same source, which had been performed 6 months later than the second one shown before, where she has seen the first, the source, the transient source, the one of with a big blow showing it. The suspicion was at the workshop after that, after observing this, that it could be a transient magnetar. Magnetars are neutron stars with an extremely high magnetic field. They are considered unique laboratories in the universe for studying physics of ultramagnetized objects. Okay. Neutron stars are already exotic, although in between pretty usual sources in the X-ray astrophysics world. But magnetars are the exotics of the exotics. Their large X-ray emission cannot come from a loss of the rotational energy, like in the case of normal pulsars. Their brightness are too high. The theory of magnetars solved the puzzle around 20 years ago of the so-called anomalous X-ray pulsars or soft gamma repeaters. These were different things which were actually the same, but they were called accordingly to the range of the spectrum they were observed in X-rays or gamma rays. The energy behind the luminosity of the magnetars comes from the loss of magnetic field. Within these exotics, there is a special class of exotics, those with comparatively low magnetic field compared to the others. Of course, these are all with very high magnetic fields. And among them, there are the transient magnetars. If we go fast through the theory in a nutshell, good for me because I'm not an expert in this field. It tells us that the neutron stars suffer star quakes, making them unstable and producing quasi-periodic oscillations, as you see here. Magnetars have magnetic fields, or this is the theory, magnetic fields twisted up inside and outside the star. Their magnetospheres are filled by charged particles trapped in the field lines, interacting with this surface thermal emission. All this is producing a very unstable system, and this behavior, this transient behavior, comes from stresses which are built up in the crust of the star, causing glitches and flares. The combination of spectral and frequency properties, together with the non-detection in other wavelengths of the object, brought the authors of this paper, led by our student Ping So, that the found object is really a transient magnetar, and the one with the longest period, 12 seconds. This was the 9th discovered magnetar at that time, and the 3rd of a special class, which was discovered at that time, of low magnetic fields. I put here for the specialist some inferred properties of this magnetar. But let me show especially the characteristic age of this magnetar, which is calculated to be of almost 2 million years. And this is contrasting with a supernova remnant age of 6,000 to 7,000 years. During the workshop, there was even the hypothesis that the magnetar could be related to the supernova remnant. Also, that means the final product of the supernova explosion producing also the remnant. But with a proper calculation, which were done in the preparation of the paper, this was fully ruled out, because of these differences. So it's just by chance that the magnetar is close to a supernova remnant. The idea, the hypothesis was that the position of this would have implied a large velocity, of large movement of the magnetar, of the neutron star, to the south in this time, and so on, and it would have been very exotic. So the discovery was already important per se scientifically, but the fact that it was done by a student during a workshop was, of course, sensational for the press, and of course we haven't lost the opportunity, and Ping So became famous. My conclusions here, they go in different directions. The discovery of a magnetar during a capacity building workshop shows, on the one side, the importance of active modern archives, like the one which is offered by ESA for this XMM Newton project, offering the data in a very useful form, data which has been processed with a thorough calibration, cleaned out of artifacts by that project. But also that together with the data, the analysis tools are provided for deepening the filtering, performing interactive analysis, and obtaining for the single case of study the best signal to noise, which in many cases is crucial for the analysis. And on top of that, the importance of extending worldwide the usage of those data and tools which are offered by the projects. And so this is nothing more but nothing else than the confirmation of the principles which are behind the COSPAR capacity building program. Now, with a bit of water, let me come to the future. It's a long talk and I start to get problems with my throat. We see a good portion of this future in doing capacity building with small satellites. There are multiple reasons for doing capacity building in developing countries with small satellites. This area represents a good portion of the scientific future. Thanks to the so-called new space based on small sats, the traditional barriers preventing access to space are almost disappearing, or they are getting lower and lower. For instance, in 2018, more than 250 satellites with a weight between 1 and 50 kilograms were launched worldwide. This number is expected to double or triple every 5 years. Not only nanosatellites are accessible to developing countries, they are also more prone to collaborations. They are mainly multidisciplinary. They call for multidisciplinary work. This is a multidisciplinary environment. This represents ideal conditions for capacity building, also due to the diversification of tasks and the possibility to exercise in one mission all the technical steps of design, build, test, operations, and even science extraction and results analysis. The need of a local laboratory in a developing country for making possible to perform at least some of the related tasks has to be seen very, very positively. While implying a somewhat larger local investment than a normal, what we call normal workshops, this ensures a long-term commitment, but it's also the warranty that the local funds are invested in own resources. Finally, COSPAR has adopted a strategic plan in March 2019, recommending the assembling of an international consortium that will develop, launch, and acquire data from a constellation of small satellites for space weather studies. A scientific roadmap has emerged from that, which would constitute a fantastic source of experiments. A task group has been formed, which is working. Okay, anyway, I should mention that although some of the main actors in this task group, in this initiative, and our initiative, and we could have a lot of synergy, the capacity building initiative with small sats is in principle independent of it. So we don't depend that they are that is a success. This COSPAR scientific roadmap. We are in principle trying to set a new path for capacity building within COSPAR based on the establishment of local laboratories in universities of developing countries, or expanding them if they are already there, and training the students to work in small satellite development areas through collaboration with international projects. How do we think this could materialize? Capacity building in this area should be done largely at project team level rather than at the level of individual scientists, like in the case of our normal workshops. And this is due to the eminent multidisciplinary character of the work to be done here. A large involvement of those universities would be required, which intend to form part of the program, and including a long-term commitment, making possible the development of a laboratory, of a local laboratory. This lab should make possible a collaboration in one or several areas with running small satellites program, constituting capacity building across campuses and nations. And here is where we met INSPIRE, as an ideal partner for these purposes. INSPIRE is a consortium of global space universities led by the Laboratory for Atmospheric and Space Physics, LASP, with their site in Colorado, in USA, in Boulder. This organization, this consortium, INSPIRE, is already having a capacity building program based on the development of so far 7 small satellites, 2 of which are ready to be launched and just are postponing their launches due to the pandemic. Each one of these 7 INSPIRE small satellites proceeds from concept to flight in 3 or 4 years. And this provides opportunity for undergraduate and graduate students to involve in this small satellite design, building, testing, and operations, all the whole chain. Our intention as COSPAR Panel for Capacity Building is to help universities in developing countries to join this program, getting guidance and know-how in space hardware and instrumentation development, and so raising the awareness in the developing countries of the potential, of the big potential of small, low-cost satellites to contribute to science, engineering, and education in those countries. This is the map I have already shown, but now with the distribution of the INSPIRE nodes, which helped us to think about regionally distributed efforts with regional support to universities from developing countries in the region or close to their, more or less close to the region of one of these INSPIRE nodes, for a long-term collaboration, helping with the build-up or the consolidation of a local lab in the university in the developing country, and dealing with one or more of the activities related to these projects which are running in parallel. In this sense, the capacity building would not be centered on the individuals participating, but more on a sustainable project for the selected universities. They could have generations of students working on one project. Now, superposed to the map, you see again the places where we have held our workshops and plan the next. In principle, all of them in this year. Okay, there is a certain correlation, and we are going to use the correlations which exist there to go in this way. Now, since the collaboration between COSPAR and INSPIRE developed in parallel for both purposes, for the establishment of a constellation of small satellites for space weather studies and the development of a capacity building initiative with small satellites, both are perfectly complementary, we could summarize the partnership around these key objectives, these 4 points. The international cooperation for pursuing science goals in space, weather, monitoring, or climate change, to provide coordination among the different nations and universities to address the COSPAR goals, to provide capacity building across campuses and nations, enabling space hardware and instrumentation development, and to provide guidance on best practices for hardware development, sustainable space activities, and crafting space policy among emerging space nations. Actually, our capacity building project with INSPIRE should have started last year. The idea was to add, since the process of getting the summer school of LASP was very advanced at the time we have decided, we thought actually in adding just one selected COSPAR funded funded team from one university in a developing country to this usual summer course, and to work for 8 weeks in Boulder on integrating hardware for, actually it was for Inspire Sat-3 mission. This is a mission which is led by the US, India, and Singapore, as well as to work on the concept design for future satellite, for Inspire Sat-6 satellite, which is led by Taiwan. This failed due to COVID-19. And so now we are thinking in trying to implement as soon as possible, if possible in 2021, if not in 2022, a plan which is based on the extension of Inspire capacity building activities to one or several of the member campuses, and giving the access to the developing countries through COSPAR for this point, for the provision of technical assistance, for satellite development, testing and operations, for project management and systems engineering, calibration and test facilities, and the support for building up the local labs in the participating universities. That's the main point. So we have started to look for funding. Such a program, as described here, is very flexible, but in principle more expensive than our usual workshops. And we will need a good deal of external funding on top of COSPAR that could contribute to a certain level. So external sources could be the aerospace industry, but also large space agencies. And of course, a good level of local contribution is again expected from the interested universities. The results of local investments could be immediately rewarded in this case through the laboratory, which is growing up. People are getting prepared, specialists are coming to help with the build up, etc. Especially interesting, in my view, is the fact that this is perfectly scalable, and even very small levels of cooperation could fit in the scheme. So universities with low budget could participate in some way. For the space agencies, but especially for the space industry, supporting such a program should be appealing. We have already contacts to the different organizations. While we receive already for our traditional capacity building program a certain level, a good level of support from the large space agencies, ESA, NASA, and JAXA, on the other side, the space industry is already supporting the Inspire program. I think one of the fundamental steps ahead is awakening the interest in universities in developing countries, raising the awareness that such an opportunity is feasible, reachable, and I would think very favorable for those universities. This can be done through different measures. Our organization, COSPAR, will help here through all our international contacts. We are planning to do presentations, webinars, but also virtual visits to the Inspire centers should serve as a source of inspiration. This should be implemented by our Inspire colleagues. The development of this so-called COSPAR initiative for a constellation of small satellites could result also fundamental, but we don't want to be too dependent on it since they could have different bases, different times involved. In my view, the conditions are already met for launching this new program, and good since India is a traditional place for us to organize workshops. You have seen in the map that there were several workshops organized in India in very different subjects. I think the collaboration from your side, and expect some of the people watching this presentation, they help us in raising this awareness by the universities. There's even a company, Berlin Space Technologies, who has a already capacity building program based in India. It's a German organization, but they have factory in India, and they are already having a local program. We are in contact with them, and we want also to join efforts with them. So I would say, let's work on it. So now let me come to my summary with this nice poster of an event we had in, I think, yeah, it was in Argentina, my country of origin, around 2011 or so, 2010, 2011. So I would say that the capacity building program is in very good health. We have increased the number of workshops in the last years, and we are further diversifying them. We are increasing the collaborations with other capacity building organizations. For instance, at this time, I'm collaborating with an oceanography workshop, which is taking place online in Malaysia. We are maintaining or even increasing the number of fellowships per year. We are starting with the alumni program with excellent first results. And we are fundamentally preparing the new type of workshops based on small sats and nanosatellites. So, and with this nice picture of coming from my participation, as you see in Holi, during Holi in Mohali 2 years ago, I end this presentation also with a very nice Rajasthan meal in a restaurant with our students as our gala dinner. I finish these presentations and open the floor for questions yes. So I'm going to
thank you so much, Carlos.
The sharing. Let me come back to. Okay, now I'm done.
Thank you so much, Carlos, for this nice presentation. And you have covered all the possible aspects of the capacity building, which is being led by COSPAR. And probably everything is very crystal clear to all the audience, and whatever the possibilities are there, they will be able to check with you. And the only thing, because we have been discussing that the basic science, the things are being covered mostly in the COSPAR. And recently you discussed about the nanosatellite development, which is, the new thing, what you have said, like it is a new horizon. So, what kind of the possibility of the technical training is there as far as undergrads are concerned?
Yeah, it's pretty early to tell exactly what are the possibilities, because we are trying to implement the program. The program should be actually going in the direction of more undergrads than our traditional capacity building workshop, which was more for PhD students. The nature of the work to be done in the development of small sats, including all these different steps, this calls actually for people following it for a couple of years. And the idea is, okay, we establish a local lab where people can work. The idea is that a first training of a couple of weeks is taking place at one of these Inspire nodes or other nodes if they appear with further collaborations. We are working now practically trying to implement it with Inspire. And I would have expected that this is happening this year. But the pandemic is putting us on hold. So there will be definitively possibilities for undergrads to work on this because of the nature of this work, and even more engineering studies than basic science studies, which are the main part of our traditional capacity building program.
Yeah. So basically that is the main concern, because when, as far as the development is concerned, and when it comes to rather than engineering rather than the science, so basically that more active approach is expected. And whenever we are discussing this, the science part, so in that at least, a kind of prior knowledge is required to just understand and the plan any scientific missions. But when it comes to the engineers or different students from different streams, like from computer science engineering, from electronics and communications, and even from right now, that new branch that artificial intelligence has also come. So it is growing a lot, deep learning and machine learning in these fields. So basically, like if we talk about even the space science and various aspects of the space weather effects, we have been thinking that, the signatures, whatever are there in the space weather phenomenon, just to, because we are sending the small satellites. So in case to recognize those signatures before that, the processing of the data, so well beyond, so that it can help us in that basically the forecasting the phenomenon, what is going to happen in the near space environment. So if that kind of, the data pipeline and these things are involved, and if it can be explained to the undergrads, so probably they will be having somewhat clear mindset while pursuing the science as well as technology, as far as this COSPAR initiatives is concerned, and the satellite developments are also there. So with this, my question is there that are we planning something in the coming future that where we can include the different aspects of the engineering in this capacity building field?
Yes, I think I try to make clear that this is highly multidisciplinary here, what we have. So we have space for several types of people working this project, from the guy who is putting the hardware together, a technician, an engineer, and so on, to the guy who is going to analyze the data as it ends, and interpreting the results of the observations performed. So it's a large collaboration between people from different fields here, and this is making especially appealing for developing countries this type of workshop. This and the other effect, which I try to make clear in our capacity building workshop, we are actually preparing individuals, and we don't reach this 100% result of helping the developing country, which is our main aim. Our main aim is not to prepare you or another colleague to be able to work in the US or in Europe. Our main aim is to help India, in this case, with the development of science there, science and technique there. And so in the case of small satellites, this is exactly the point. We know that we are helping directly the growing of these capacities in the country itself.
So the last thing, what I'll just want to hear from you, one question, like that we have already identified some Inspire Center in India. So as far as India is concerned, and such a huge country with very diverse population and with very diverse interests. So if we want to put together their efforts, and there are so many growing and new institutions as well, and they are looking forward to work in this particular field. So what kind of supports the new institutions where they are planning to establish such kind of facilities they can get from COSPAR, and which can be channelized to the already established Inspire centers or other satellite facilities?
Yeah, the idea here is that we are going to help not only for the establishment of new labs in some universities which they don't have, but also to help labs which are already existing to develop. And the development should be linked to projects which we know are going to be successful because there are people working in central places with big plans and so on, and they have a lot of knowledge and expertise to work on this. I mean, this is why, actually, if I tell the real story, we were scratching our heads trying to see how we can do a capacity building with small sats when we suddenly met Inspire. And Inspire, that was an inspiration. It was an inspiration really because they are already there. They have already 7 satellites in a different stages of development, and they have been put together partly by students and partly by students from some countries which can be considered developing countries. So meeting them, it was ideal. Now, our idea is that we should try to help all the developing countries around them, but also these countries which have already these initiatives to help with that. So how we are going to help? How is COSPAR going to help? COSPAR is going mainly to organize and to put the efforts together to crystallize this. COSPAR is good in linking people and efforts. That's our main thing. It's not so much money. This is the reason why, actually, for this plan, we need actually money from the space industry or from the space agencies and so on, because it can be expensive. Huh? I mean, we have to move students, and then we have to move specialists from the places to the universities in the developing countries and so on. But we are making good progress, and if we couldn't be this damn pandemic, then I think we would be in a much advanced stage at this point, because we are understanding we are understanding ourselves with inspired people very well, and have the same. It's also a fact that many of the people working in Inspire and working in this COSPAR project, we are coming from developing countries. Insofar, we have a real interest that this is happening. Yeah.
Yeah, okay. Thank you so much, Carlos. Even I have been benefited by the COSPAR initiatives. So many times I have been part of COSPAR Symposium, and last year I attended that nanosatellite workshop in Israel. So once again, on behalf of VIT Bhopal University, I thank you for giving us your precious time, and you have joined VIT Bhopal on this particular platform. So on behalf of VIT Bhopal and the participants, I thank you very much for your efforts, what you have put here. And definitely whatever information you have given, the society will get benefited. And basically you have combined all the possible information in single platforms, so which can be used for other references as well. So as far as the capacity building initiatives are concerned. So thank you so much for joining us. Thank you.
Okay, thank you. It was my pleasure, and I have to thank that you have given me the opportunity to talk to so many people here. I have to thank you for helping me in this project. So I did it with my highest pleasure.
Yeah, it's our pleasure. Okay, thank you.
Okay.